So there's our rectifier. This H bridge will end up being part of this circuit here, which is the power module.
对，是这个是这个吗？
That's a MOSFET, isn't it? Yeah, it's not. Yeah, that's yeah. Unfortunately, I don't think you've got one because you don't deal with ecos, do you? Okay.
对啊，对。
All right, all right. Well, what I'll do.
来说 ，IGBT
Don't worry. What I'll do is I'll draw it out.
整个的。
I'll draw one out physically, so you've got a better understanding. Because you've all seen. Well, I don't know if you've all seen inside the eco, but inside there you've got maybe 6, 12, or whatever configuration the machine is of IGBTs. Now, what is an IGBT? Well, IGBT is basically a power switch, and it consists of, obviously material that has certain properties, and one of them, one of the main attributes for it is that it's high power switching at a reasonably high frequency, or a given frequency. Generally, around about 200 kilohertz is the nominal. But you can get a lower frequency like on the top here. No, that's also a H bridge. That is a H bridge, but it's MOSFETs. Same sort of thing, they're using MOSFETs here instead of IGBTs. But it is effectively the same thing. So in that configuration, you still have the same what's called H bridge configuration. Right, so an IGBT will consist of power modules, and you've obviously got more than one power module, and they're usually, well, they are, in parallel. So you might have a series of 6 or more, literally. And here, where we call the power module, or power module assembly, you will have this sort of configuration. It's a pity we haven't got a generator, I'll be able to show you. So, if I remember, you've got gates here, so that will be the AC side. So that will be the AC. This will be, sugar. I think that's the negative, and I think that's the positive. But don't quote me on that, it's just what I'm trying to remember. So, physically, on the IGBTs, you will have DC connected in the form of copper work, copper plates and things like that, connecting all the negatives and all the positives. So this will be the positive, that will be the negative. So that's on the power module, and these are the outputs. So with, say, a 4 configuration H bridge, you will have the AC out, so you've got DC here, and let me do this properly. So these are your outputs, this is your DC inputs on the power modules. These are your gates here. It's pretty much got a photograph of it, so 1, 2, 3, 4. In the case of the power module that you've got, I think we've got more, but don't take this circuit. Just think of what they do is that they use a certain amount of, there's 2 sets of switching power modules on each one. So I'm just giving you a general idea to make it simple for you to understand. But you'll have a multitude of switches on there that you don't know about, but it's basically the same. So what happens is that when this is ready, it switches on an asymmetrically configured switch. So you'd have something like, this is your output, AC output. And inside the equipment, you'll notice that there's a capacitor, and there's also, once again, this bit here, series inductor, or choke. So there's your choke, and there's your blocking capacitors. That's the basics of this circuit here. That's the physical, what it physically looks like in the form of buzz bar. These are copper links, obviously. So this comes around here. Oh, no, so the comes around on there. So this is the physical diagram of how it works. So you've got your IGBTs, you've got all of them linked in the form of copper work or copper assembly, and then you've got linked copper assembly, which are really close together with insulation to stop any stray inductance. So you won't have them like this. You'll notice that all the copper plates are very close together. And it's important that it stays like that as well. Right, so that's the basic circuit. So what happens is that when it fires asymmetrically, which means that's open, that switch is open, this closes. And that closes at the same time. That one and that one close at the same time. So it's 1, 2, 3, 4. So 1 and 4 go on at the same time and close. That allows the current to go through here. And then there's a short delay. Then it goes in the opposite direction. The current then goes in that direction. So you end up what we call an asymmetric firing. And what happens is the output goes positive when these are on, slight delay, and it goes negative. It goes positive. That's basically what happens. So your output here is going positive, negative, positive, negative, positive, negative. That's the basics of the H-bridge configuration asymmetrically firing circuit. You're happy with that? Right, now, how do we control it? How do we control the power? Well, we use a pulse width modulation on the circuit, which means on the DC supply, we control this power using a pulse width modulation or modulator. Now, how does that work? Is it okay to draw on this side? Yeah. Anybody know what or how pulse width modulation works? What we're going to do now is, okay, so you've got it oscillating, right? Now, the fact that that's switching positive and that's switching negative means that the current is going back and forth in this circuit, i.e. this circuit, right? Now, when it comes out here, it's a rubbish waveform. You know, if you imagine this, in fact, I got some from China at a company called, it was a military establishment. I won't say the name because that's non-disclosure and all that. But it was a military establishment where we had a bit of a problem, or I had a bit of a problem, and the only way I could fix it was to measure the waveforms here, which is a bit dangerous because you're dealing with high voltages and high frequencies. But when I did measure it, you had a really crappy output from here. But on the primary here also, it was pretty crappy. You know, you could just about make out that it was a sine wave, but not much else. But on the output, which is, this is the primary of the transformer, of your power transformer, and then you've got secondary. You've got an isolation transformer, and then the output, which is basically here. So this is this. This is your tank circuit. This is the RF transformer. There's your primary. There's your secondary. This waveform here was crappy, you know, like this. But here, it's a pure sinusoidal waveform. So, with all this switching going on and all the rubbish that gets developed on that primary circuit, it does actually end up with a very nice sinusoidal waveform on this output here. And it's isolated, it's not physically connected. So your output workout is not physically connected to any of this, it's isolated. That's another thing to remember.